I want to talk about arrays. So variables are great and all, but they don't just get the job done for a lot of more complicated situations, and you can see your scripts filling up with a lot of similar variables doing similar things. You might have transform for like enemy1, public transform for enemy2. You might things can get kind of messy. You have 3, 4, 5. You have a whole lot of there we go. And you're doing the same script on the same things, and it just doesn't work. Sometimes you need to manage like a number of different but similar objects, or a set of data, or like all of the levels in your scene, or a continuously changing and updating flow of information that we want to keep track of, like a history state. So let's say we need to keep track of every enemy on the screen. Perhaps you want to figure out which one's the closest, or make them all turn into blue ghosts when the player catches a power-up. We could have a enemy reference variable for every single enemy and assign it in the inspector, but sometimes enemies get destroyed and sometimes they're not destroyed, and it would get very sloppy. And our code would look really repetitive. Enemy 1 dot destroy, enemy 2 dot destroy, enemy 3 dot destroy. It would look awful. And then, the designer comes in and you're like, I think we need 20 enemies, and you're just like, oh no. I have to write the same line of code 20 times and everything. It's no good. There's a solution, and the solution is arrays. So instead of keeping track of every enemy separately, we would make them into an array of enemies, which is basically, arrays are a single variable that contain a set of variables. Any data type can have an array version of itself. Almost any data type can have an array version of itself, but I can't even think of an exception to that rule right now. We can have arrays of colors, we can have them of numbers, we can have them of booleans, we can have them of game objects, reference variables of things in our scene, we can have them of vector 3s and structs, and we can even have arrays of classes that we created ourselves. We can make arrays out of anything, which is awesome. And the way to make an array out of something is just to add these square brackets. And there, now it's an array. So arrays are a single list that contain a set of variables, and I really want to use the word list to describe them. They're a list. It's a list of enemies. But and in English, this is a perfectly accurate word. I'm talking to you out loud. It's a list. But in C#, lists are actual things, and they're really similar to arrays. The differences between a list and an array is something I will allude to this video, but talk about at a different place. So let's not use the word list. But they're lists. All right, so let's go back and talk about our understanding of memory and the computer's use of variables as part of its use of memory with this spreadsheet, where the variable is the address, the sort of lookup, the ID number, whatever you want to call it, and this is a RAM, and the variable is the value. So maybe we have a float up here, maybe we have, where am I changing colors? Maybe we have some color here, and it's red, whatever. An array is a single array. So let's say we have an array of integers. A single array here, I'm going to call it triangle because I can't draw with my mouse words very well, obviously. So we have an array of integers, and that would be it would be the value 1, value 2, value 3. It would just contain all of them listed out in this one block. Like that. So the array has all of its values sort of there, and to get at the array, you just have to tell it which one. I want the first item in your list, I want the second item in your list, I want the third item in your list, I want the fourth, and it'll just get the right one. So when we create arrays, we need to tell it how big it's going to be, because it's going to create all of these slots when the array is created. So we can't grow the array while it's working. There are other programming languages where you can change the size of an array after you've created it, but C# is not one of those languages. And if you needed to change the size, hey, that's what a list is for. But again, different video. So to get at the the thing, the enemy that you want, if we have our enemies, we use square brackets, and then we type the number that we want. If we wanted the first enemy in the array, the one stored right up at the top, we would simply type 0 for first. And if we wanted the second one, we would type 1. We wanted the third one, we would type 2, and so on and so forth. Because we're programmers, we start counting at 0. And that's you just have to accept that. There are memes, it's a thing. Programmers started counting at 0. The first element is at position 0. Just accept it in your soul. Learn this truth of the universe. Get a tattoo of it engraved on your forearm so you'll never forget. Every programming language ever written, except for ones that are just like meme languages that are doing it different to be annoying about how this is such a thing, start counting at 0. So index 0. There it is. Okay, that's how arrays work. Live with it. So the first element we want 0, right? And then now this whole thing is just as if we got it is a transform, right? Because this is an array of transforms. So when I hit the 0 there, this becomes this is representative of a single transform. When we create the array, we need to define how large it is. That's really important, as I mentioned before. So to do that, we type new, sort of like making a vector 3 array, and then we give it its size. So this will be an array of 5 enemies. And then now I can do and now I can get all of them from position 0, position 1, position 2, position 3, and position 4. The last 5th element in our array is at position 4. These need to be lowercase. No, they don't. These can't have numbers. You can't start a variable with a number. Anyway, I just was too lazy to type out the words. So we create the array of whatever data type we want, an array of integers, int square brackets, numbers equals new int square brackets, and then the size of the array. 10,000 elements in our array. Whatever. That is everything I wanted to talk about with arrays, except let's look at 3 different useful patterns for how we use them. So let's get rid of this code. And first, I say we always need to create them and declare how large they are, but you don't always need to type that. If it is public, you can go into Unity and you can create it in the inspector. There's a shortcut to this. I always remember. You can drag and drop. There you go. Enemy 1, enemy 2. You can drag them in. So now my Unity inspector has basically created the array and made it the right size for me. So that's very useful. So second, we can just define arrays literally. So maybe we have some void check all directions. So maybe we have some function that takes a vector 2 direction, and we want to check every single direction around us. We could do check direction vector 2 dot up semicolon check direction vector 2 dot down, and that would work. That'd be fine, but instead we can make an array, a vector 2 array, directions equals new vector 2 array. Instead of saying how big it is, I'm just going to use curly brackets and type my vector 2 dot up 2 dot down, vector 2 dot right, 2 dot left. There you go. And you sort of, very similar to a function, you just use those curly brackets and then just list them all out, and that'll make one that's the size 4 vectors large. So that's the second thing, is that's your syntax for declaring arrays directly. There you go. Semicolon. You list them out. And you can use the fact that C# doesn't care about line breaks to make everything look pretty if you want, if you had some larger data type. I see that a lot in other people's code, people who spend more time on making their code look pretty than mine. And next, the final thing is that, and I'm sure every programmer ever has written the following line of code. So like, get ready. This is going to be a very common pattern. You will see it all the time. And that is a for loop that iterates over every element in an array. So for integer I, and now we can think that I stands for index. Set it equal to 0. And then we will loop as long as the following statement is true, as long as I is less than directions dot length. So every array has a dot length value, and it's an integer that says how many elements there are. So in this case, it would be 4. So while I is less than 4, I is less than 4, I plus plus. Where is my, there we go. And then to get at the value, we just, as before, we put the square brackets, we put the index that we want in the square brackets, and for us, we can just put I in the square brackets. So we'll start at 0. It'll get the first element, it'll go to 1. It'll get the second element, it'll go to 2. It'll get this third element, it'll go to 3. 3 is less than 4. It'll get the fourth element at position 0, 1, 2, 3. And then I will become 4. 4 is not less than 4. It is equal to 4, so it's not less than 4. So then it'll stop and move on. So for int I equals 0, I is less than the length of the array. Go up by 1, and we can loop through everything in that, or we could, we could destroy some public function kill me or something. That doesn't exist, but we could destroy every single enemy in a list, and so on. And that's everything I want to talk about arrays. I'm going to show one more here at the end. I'm going to show one more sort of example bit of code that you might find interesting, which is a searching through an array to find an item. So if you're good, like, close the video, you're good, but here's another pattern that you might find yourself using. And we're going to start by iterating through an array. So we have our array of enemies. It's a transform of all their positions, their transforms. So, and I want to find the closest enemy. So I'm going to loop through, start at 0, go throughout their length, increase by 1 each time, put this bracket on a new line, which I definitely always do. And then we need to check to see how far away our position and this enemy we're checking's position is, and if we subtract them, and then take the magnitude, and magnitude is always positive, so it doesn't matter if this is going to be a positive or negative direction, this is going to get the magnitude. This is now a float, so subtracting them has turned this parentheses into a vector, and then the magnitude of the vector is their distance away from each other. So now we're going to make float min distance equal to really high, and float transform closest enemy equal to null. So if the distance that we are away from this enemy is less than the min distance. Let's type closest enemy distance. If this enemy is less than the closest enemy distance, then we will set closest enemy distance equal to how far away we are from it, and we will set, I got rid of a curly bracket, didn't I? And we will set closest enemy equal to this object. We'll clean that up a little bit. Great. So that capitalized. And now, after we've gotten through this list, closest enemy will be equal to the closest enemy, whichever one is the nearest distance. And you could use that to determine, you know, this function here where you're checking something on every variable. Like, you could use that on anything. You didn't have to do this whole vector math to figure out the distance away. So one more time from the top, we make a variable. I believe there's a constant for infinity. Yeah, great. So we make a variable for infinity, which we can just use in the place of a float, and if it'll, you know, if we use it in a conditional to see if something is equal to it, or if less than or greater than it, you know, it's infinitely far away. That's so any number is less than infinity, so that'll always be true for the first enemy. So we set that enemy's distance to be its distance away, and then we check the second enemy, and if the second enemy is closer to it, then we'll change it, and if it's not closer to it, then we won't. And after we have gone through every single enemy in the list, we know that the one that has survived this this comparison must be the closest, because it's closer than all the other. None of the other ones are closer than it. So we get to the end. Now let's take this function and let's put it in its own, or that whole thing, and let's put it in a function, transform.get closest in list. Get closest. What am I doing? Transform get closest transform, and it will take a list of transforms. Things. So here's a function that will boop, and all I have to do is make those say things and return closest enemy, closest thing. So I have abstracted this code from checking the closest enemy to now just checking the closest of anything in a list. Closest distance, we'll just say that. There. So now this code, I have abstracted it, I have generalized it, so some other things we were talking about in programming, into its own function that I can use wherever. And then, just like before, debug.log, the closest enemy is this one. Plus closest, get closest transform, that's what I called it. Give it our list of enemies. Game object I made. Great. So, leave it on the screen for a moment for you to pause the video, and then let's take a look at it working. So, here's my error. Missing a semicolon. Classic. Love it. All right. So we have an enemies. The array is populated. We hit run. And the closest enemy is this one, enemy 4. Enemy 4. Click. It's this one right here. It did it. We did it. So I guess it's important to note that looping through all of the enemies in a list, especially as that list can get to very large, and checking a position of every single one, this isn't necessarily the most efficient code. Programmers will fight for honor and glory and blood to the death over writing the most efficient search function to take a bunch of elements in a list and find one thing. We are finding the closest thing in a list. It's fine for a lot of just the small, simple stuff we're going to be doing. If you just, we're looking through directions and a small number of enemies or objects on the scene, things like that. And if you made it through this far, no, I was about to throw more extra stuff out there. Let's just end the video now. Arrays, they're pretty great. It's tough to think about when you will be using them or what you could use them for. They're just like this useful generalized thing. So hopefully seeing these patterns that I have used a lot. I've made arrays of directions a lot. I've made arrays of enemies in almost every game I've ever had enemies in. So hopefully that helps you kind of get a sense of what we might be using arrays for.